Hi guys, today we'll be talking about tutorial week 5. Question 1. There are two import sources of memory address. Explain how the circuit determines the source of 4-bit input memory address to the 74LS 189 RAM modules. Okay, so before we look into the question, we need to know that there is two input of the memory address, which is one is from the switch and another one is from the bus. So by doing this, we will be using a switch, and the switcher will be connected to the 74LS157, and now we will look at how the 74LS157 works. Okay, so basically 74LS157 make up of two inputs and one select and one output. So this switch here will be connected to the LED, two LED. The LED will act as an indicator what is in the switch, and the switch will be connected to the ground, and the red LED here will be connected to the pin 1 of this register, which is also the select pin. Okay, so when we flip the switch to the left side, and the red LED will light up, this means that the red LED is grounded. So when it is grounded, the pin 1 of this 74LS157, which is the select, is connected to the ground, which also means that this is low. According to the datasheet, when the select button is low, the A input will be high, which also the switch here. So the source, we will be taking the source from the switch here, and when we want to input from the bus, we'll be flipping to the switch to the other side, and this LED will light up, and yeah, so the data from the bus will be inputted to the memory. What is the usage of pin clear, clock, and pin MI? So the first one is pin clear, pin. The clear pin is constantly connected to low for this circuit. It is to prevent the circuit from constantly being cleared, and for the clock pin, it is connected to the clock, and it is connected to low to allow the clock cycle to read the memory. And the MI pin is basically the data enable. This will control the inputs, whether the input from the bus is being clocked in on the clock pulse. There are two input sources of memory data. Explain how the circuit determines the source of 8-bit input memory data to write the 74LS189 RAM modules. As you can see, for this question 2, we will be using two input sources, and we can choose to use program mode or RAM mode. Okay, now let's look at the circuit. Here we will be using yet again the 74LS157, and the first input of the 74LS157 will be connected to the switch, and the second input will be connected to the output of the NAND gate. So the NAND gate will be here. The first input of a NAND gate will be connected to the clock, and the second one will be connected to the control logic, and the output will be connected to this second input of the B input of the NAND gate. So firstly, if you want to run the program mode, we will press the switch here, and then the data stored in this switch will be outputted to the memory. And next, if you want to output the data from the bus to the memory, we will be setting the logic here, control logic here to high, and at the next clock cycle, when the clock cycle goes high, the new data will be inputted to the memory here. How many clock cycles are needed to put the data in register A into the bus and store it into the memory location 0 of the RAM? So as you can see, the answer that came out by us is that only 2 clock cycles are needed to put the data in register A into the bus and store it into the memory location. Okay, as you can see, in order to complete that operation, 7 operations need to be done, and the first operation is put the value 0 times 0, 0 into the bus, and operation 2 is the load pin is pulled low so that the content of the bus is stored into the memory address register. And for operation 3, the load pin is pulled high to prevent the memory address from changing. The operation 4 is that the enable pin will be pulled low. Hence, the content in register A will be presented as a bus. For operation 5, the enable pin will be pulled high again to prevent the content at the bus to be changed. Operation 6 is that the control logic is set high so that the new data will be stored at the memory at the rising edge of the clock. And for operation 7, the control logic will be set low again. So as you can see, only operation 2 and operation 6 needed a clock cycle. So in conclusion, only 2 clock cycle is needed.